just mean that size of struct has to be divisible by 8? No. How does it work? You could think of it as an imperative algorithm. Let's move this stuff back over here. Text. Size 40. So if you have some struct, and let's say assume size of int is 4, size of long is 8, and size of char, well, size of char is defined to be 1, but let's just oh, I'm saying I was lazy when I was a kid. I'm not lazy now. I mean, kind of am lazy. What time do I wake up? I try to wake up at 8 to 9 a.m. So when the compiler is reading the struct and it needs to lay it out, it'll always put the first member at offset 0. Right? First member is always 0. Offset 0. 0 bytes. So all these numbers here are bytes, number of bytes. So offset would be, if you have a void pointer to S, to some S object, and well, if you have a pointer to an S object, you could cast it to the A object, to an int pointer, and then get the A object, because there's no difference between the pointers. Pointers have the same value. For B, it would consider putting it at offset. Okay, let's add to this. Line of int is 4 and line of long is 8. It'll think, okay, well, it knows the size of int, so it's, but it needs to figure out the layout, the offset. So it takes the offset of the previous thing, it adds the size of the previous thing to get 4. Then it says, is 4 aligned to int's alignment? Which basically is asking, is the offset evenly divisible by the alignment? So because 4 is evenly divisible by 4, we're good. Like, it just uses the sum. It looks at C, it says C size is 8. It needs to calculate the offset again. So it takes the offset of the previous thing, the previous member. It adds the previous member's size to get 8. So 4 plus 4 is 8. Then it looks at, and then it tries to align that, which means it'll see if 8 is this offset is evenly divisible by the alignment, which is 8. Because it is, then it doesn't change the number. So all of these things are aligned. So A and B and C are aligned, and there's no extra space made between them to force that alignment. They just happen to be aligned by the structure. Now, if a line of long was different or sizes were different, then that might not be the case. But we're assuming that these are of what we have. So if we look at D, which is our character, our char, we do the same thing. We take the offset of the previous thing, we add the size of the previous thing, and we get 16. Then we check, is 16 evenly divisible by the alignment of char? The alignment of char is 1. 16 is evenly divisible by 1, so we leave it there. So that's the right offset. Then we look at E. Its size is 4. Its offset, we're going to look at the same as before. We look at the previous offset. We add the previous field size to get 17. Then we ask, is 17 evenly divisible by the alignment of the int? 17 is not evenly divisible by 4. So, what can it do? We need to make the offset of E evenly divisible by 4. In other words, we need to align E. So we can either, the only sane options are reduce offset until it's aligned or increase offset until it's aligned. If we reduce it until it's aligned, then we end up with D and E overlapping because D also has offset 16. So we can't just reduce it. So what we do is we increase it. So you keep increasing it by 1. Like one way to think about it is you can keep increasing it by 1 until it is evenly divisible. So 18 is not evenly divisible, 19 is not evenly divisible by 4, but 20 is evenly divisible by 4. So it ends up that E, and then we stop there. So E has offset of 20. So there's this implicit padding starting at offset 17, which is the end of D, and that goes through to 19, which is just before E. So there's this implicit padding, which is, padding means just wasted space in the structure. So this is basically how alignment is done. So this isn't the only, there's one more piece, which this example doesn't demonstrate. Let's put another thing in there, char F, just for a safe example. Let me tab to align these, because I'm triggered by, I could use a mono font, whatever. So here we do the same thing we did before, where we take the previous offset and the previous size, we add them together to get this offset. Make sure that the offset's evenly divisible by 1. Of course, any integer will be evenly divisible by 1, so we're good. Then there's another thing that C does, which is it makes sure that if you have two S's next to each other, that they will be aligned, all the members will be aligned correctly as well. So the way it does that is it adds extra stuff at the end. So how do I explain this? So you can imagine there's an extra thing here. Extra. And the extra thing would take there's like some extra magic thing here. Let me move this up. There's some extra, it pretends that there's some extra thing down there. Move this up as well. Oh, I don't want to move the background. And the extra thing will have no size, but it'll have an alignment. So we could say, so how does it determine the alignment? it does the maximum of all the alignments of all the fields. So I didn't write down an alignment column, but in this case it's all the same as the size. So the maximum alignment is 8, which is our long C here. Alignment is 8. So it'll take that alignment and it'll do the same calculation. It'll like determine an offset just like it did before, as if this was a field. So we take 24, we add 1 to get 25, and then we try to align 25 to 8. So is 25 evenly divisible by 8? No, it's not. So we need to keep incrementing it. So not 28, not 30, I think it's 32 is the next thingamabobber. And then this will decide the size of the whole structure. So this means that size of S is equal to 32. So that if I have two S's next to each other, then they will be appropriately aligned. Also, a line of S would be 8, because you take the line of is by default the maximum alignment of all the members. That is correct, Bot Felk. In this case, you would probably put these chars next to each other to save some space. That would save 8 bytes in this case, if you put the chars next to each other. So I want to minimize padding when designing my structs. Sometimes. If you want to index into the data a byte at a time, you want to be packed so you don't have to deal with skipping the padding. Yeah, there's better ways to do that. That kind of coding is tricky, so I avoid that. But in general, yes, you would want to avoid padding, because the larger your structs are, the more. It's not the fact that it takes more memory. It's the fact that every time you need to access memory, you're accessing at different locations that aren't as close together, and because they're not as close together, the CPU has a harder time observing your access patterns and helping you out with its caches and such. But if you have a lot of like this struct, then you'll get possible memory reduction in memory usage if you remove some padding. But if you only have like 2 of these structs, 2 objects of the struct, and if you're not accessing those members in a loop or anything, then the order doesn't matter, really. If you have a struct larger than 8 bytes on my 64-bit system, it would make sense to pass a pointer to the struct when passing to the function. Not necessarily. It depends. The real answer is measure. But if you want a good default, then some people say 8 bytes, some people say 16 bytes. I mean, there's no right answer except measure. New instructions won't even work if it isn't aligned correctly. No instruction will work if it's not aligned correctly, because the C standard requires that things are aligned appropriately. And if you don't access them aligned, then it's undefined behavior. Well, it's just good old software engineering. It depends. There's no objective answers for a lot of questions. Like, do you use int or long, or short, or whatever? Like, the naive answer is, oh, well, it depends on how much, what data you're storing in it. But there's other factors as well, like performance and memory usage and all that stuff.